Now let's demonstrate the feature selection or embedded type feature selection using ridge regression algorithm. So feature selection in predicting house prices using ridge. So selecting relevant features like the number of bedrooms, square footage, and location to predict house prices. So let's begin with our first step, load the data and import libraries. So anyway, we have discussed the same example in our previous case also. For the last also, you can look into that. So then after loading the data and importing the libraries, we have to do the some pre-processing. So here encoding the location variable using one hot encoding or any suitable encoding technique. Until that step will quickly pandas spd, then SQL learn library, model selection package, and train test split module, then SQL learn library pre-processing package and a standard scalar module, then SQL learn library linear model package, and we got the rich module, then SQL learn library matrix package and mean squared error as your module. So these are the modules we will be importing, and after that we have to load the data. So read CSV function from the pandas library and then path of the data set, that's house prices Bangalore.csv. So then let's perform the one hot encoding for the location variable. For that I'm going to call up get underscore dummies function from the pandas library, and I will give you the respective data frame and column name, a feature name or column name, and that's it. These two steps will be done. Now let's move ahead with the so next step is to split the data into features x, capital X, and the target variable y. So here define capital X as the subset of features, example bedroom, square footage, encoded location, so age of house, bathrooms, garage capacity, overall condition. Then define y as the target variable, which is nothing but the house price. Then the step 4 is to split the data into training and test sets. So split the data into training and test sets using train underscore test underscore split from SQL learn library and model underscore selection package. And this is how it works. Let's have a quick look into that. So next one is to split the data. So define the capital X where you will have all the features, and define the small y where you will have the house price, and then you split your data using random sampling technique where x underscore train x underscore test y underscore train y underscore test is equals to train underscore test underscore split, and it's going to take arguments of capital X which was defined earlier, small y which was defined earlier, and test size is 20%, random state is equals to 42. Now let's move on to the next step. So standardizing the features. So standardize the numerical features in capital X using standard scalar from SQL learn library and pre-processing package. So this is how we will instantiate a standard scalar class. Okay, let's look into that step. So next one is feature scaling. We will instantiate standard scalar class object. Then we will be feeding the respective features data into the scalar object using fit underscore transform and then transform method. So we'll get x train scaled, x underscore test scaled. So this is the scaled features we will get, and then this scaled features can be used and fit in our regression algorithm or regression model. Okay, so then what we have here is create the ridge model. That's it. Now it's time to create the ridge model. So import the ridge regression class from a library that supports ridge regression such as scikit-learn. Then create an instance of the ridge regression model specifying the regularization parameter alpha value. So this is how we do. Let's take alpha value that's equals to 1.0. Then that's our regularization parameter. Then let's instantiate the ridge regression class object by calling ridge class, and it will be a it would be given a variable name called ridge underscore model, and that's what we will be doing here. So let's create a ridge regression model, and alpha is 1.0 regularization parameter and instantiation with an argument of alpha value. And then it's time to fit the ridge regression model. So fit the ridge regression model on the training data using the fit method. So that's what normally happens, and let's do that. So here we got the ridge underscore model. This is our object reference name. This is the object name, and I'm going to call up the fit method, and inside the fit method I'm going to give two arguments. One is x underscore train underscore scaled, and second one is y train. So this data has been, these arguments has been given to that, hence the ridge model has been fitted. So now it's time to see the results of it. So next, it's time to see the selected features because the model has been fitted, the data has been fitted into the model. Now it's time to see the selected feature. Perform the feature selection with a ridge. It's pretty straightforward. X underscore train dot columns. So inside that we have to use a ridge model object, and then you have to just say coefficient underscore is not equals to 0, whichever feature whose coefficient is not 0 will be the selected feature. And now let me execute and see what all selected features we got with respect to this. And we got by and large also bedrooms, square footage, age of house, bathrooms, garage, capacity, overall condition, location, rural location, suburban location, urban. So by and large we got all the features with us. Now it's time to move on to the next step. So retrieve the coefficient estimates. That's what we got, a lot of coefficient estimates. Whatever we got are the estimates. So now let's retrieve the coefficient estimates, and we will see the coefficient estimates. So retrieve the coefficient estimates or weights from the fitted ridge regression model using the coefficient underscore attribute, and that's what we will be doing here now. So I have called up the coefficient estimates. So ridge underscore model, this is our ridge model object, and then coefficient underscore, and let me execute. You can see the coefficient estimates, and here are our coefficient estimates. You see that? So now what are the coefficient estimates I got for bedrooms? 1,53,498.4165 square footage. It's too huge. Age of house 6,63,054. Bathrooms 1 lakh. It's a garage capacity. Overall condition 70,924. Location rural, obviously the prices will fall. That's why it's a negative coefficient. Location suburban, the prices will fall. It's negative, and but the value is lesser, minus 32. Location urban, it's increases, the value has been increased, and the coefficient is also positive. And these are the coefficients which were estimated, and these are the features which were selected. So these are the selected features, and these are the respective estimated coefficients with respect to the ridge regression. So now the final step of it is evaluate the model's performance. Evaluate the model's performance. use the trained ridge regression model to make predictions on the test data. So evaluate the performance of the model using suitable evaluation metrics such as mean squared error or r squared error. So far whatever we have done, now it's time to take the trained ridge regression model to make the predictions on the test data, because the features has been selected, and then on selected features we will be evaluating the model. So let's do that. So using the MSE or R squared, so let's test the model that we got. So evaluate the model's performance. So y underscore pred. So ridge model, and then we have to call up the predict method, and I'm going to give the only one argument, which is x underscore test scaled. The test data, the data has been split into two. So one is train and the other one is test, and you have to call the test features which were scaled using the standard scalar, and then finally we'll be calling up mean squared error class from this mean squared error module, which has been pulled up from the metrics package, which has been brought up from the scalar library. So then we have to give the two arguments, obviously y test and y predict, and let's take y test as actual value and y predict is the predicted value with respect to the algorithm which was made with respect to the model which was built from the ridge regression. That's it, and let's execute and see what's the mean square error value with respect to the ridge regression. The mean square error value with respect to the ridge regression is this. Let me copy this and let me, okay, mean squared error is this, mean squared error with ridge, and let me call up for the lasso. How much I got? I got a mean square error of lasso this much. Let me scroll down and let me put it here. So mean square error lasso, which is equals to this, and okay, let me make it short. MSE, yeah. So MSE ridge, MSE lasso. Let's see the difference between them. MSE lasso minus MSE ridge, and let's see how much we got. Okay, so ridge is the ridge MSE is lesser than this, lesser than lasso. How much? This amount of staggering amount, it's lesser than that. So hence ridge regression has performed better for this model, and it has estimated the coefficients better than lasso with respect to the house prices prediction problem.